Okay, so in this very last video of the second 9 weeks, we're going to talk about two special right triangles. The first one that we're going to talk about is the 45, 45, 90 triangle. And so what you should notice about it, number one, it has a 90-degree angle, so it's a right triangle. Number two, it has two angles that measure the same, which means it's isosceles. I always stink at spelling the word isosceles. Isosceles. Still not sure that's right, but it's an isosceles right triangle. And my handwriting is just getting worse as the day goes on. But okay, so we've got an isosceles right triangle, which means that because these two angles are the same, the sides that are opposite of those are the same. So you can label those x and x. And then by using the Pythagorean theorem, you can come up with this x root 2 over here. And if you want to see the proof, it's on page 499 in your textbook. But so basically, if you're given one side of a 45, 45, 90 triangle, you can find the other side using this relationship. So if you were given a leg, you would have to then divide by the square root of 2. I'm sorry, if you were given the hypotenuse, you'd have to divide by the square root of 2 to get a leg. If you were given a leg, you would just need to multiply by the square root of 2 to get the hypotenuse. Alright, so that's a 45, 45, 90 triangle. The other special right triangle is called the 30, 60, 90 triangle. 30, 60, 90. And so this, the proof of this is a little bit more complicated. It's on page 501 in your textbook. But basically what it's saying is that the shorter leg, or the leg that's across from the 30-degree angle, is half the size of the hypotenuse. And then in order to find the longer leg, you take this number x and you multiply it by the square root of 3. So what we're going to do is we're going to use these relationships to help us solve for missing measurements in different figures. So I chose two sort of tricky examples. Here's the first one. This is a right trapezoid, and you are given a 12 at the top, a 9 on the side, and you're asked, and you're given a 60-degree angle right here. And you are asked to find A, which is this slanted side here, and B, one of the bases of the trapezoid. Now, when you have a figure and you don't know where to start with it, I would always start by trying to break it up into something you do know how to work with. And something that I think we all know how to work well with is a rectangle. So if I bring this straight down, this is a right angle, and this is a right angle. So if this is a rectangle now, this portion right here would be 12. And this portion right here would be 9. And because this is 60 degrees and this is 90 degrees, we now have a 30, 60, 90 triangle. So let's go back and remember what our rules were for 30, 60, 90s. If your short side is x, your hypotenuse is 2x, and your long leg is x root 3. And so I remember that the square root of 3 goes with 30, 60, 90 because 30, 60, and 90 are all divisible by 3. Well, I guess 45 is divisible by 3 too. But I guess the 3 and 30 just leads me to go to the square root of 3. Now in the 45, 45, 90, you're using the square root of 2. And I remember that because you have two angles that measure the same measurement. So you use the square root of 2. Alright, so here's the rule with the 30, 60, 90. So this is the 60, the 30, and the 90. Alright, so the only thing that we're given right now is this side. So we're given this. We're given that x times the square root of 3 is equal to 9. And so now we can solve for this little piece down here. We'll go ahead and label it x. So we can solve for this by getting x by itself. So divide by the square root of 3. So you get x is equal to 9 over the square root of 3. Now you don't want the square root of 3 in the denominator here. So we're going to multiply by the square root of 3 over the square root of 3. This is called rationalizing the denominator. So you're going to get 9 times the square root of 3. 9 times the square root of 3 over. And the square root of 3 times the square root of 3 is just 3. And then you can simplify this a little bit more. 9 divided by 3 is 3. So 3 root 3 is what x is equal to. Well, now we're ready to solve for b, because if we know that this part is 12 and this part is 3 root 3, we can say that b is equal to 12 plus 3 root 3. You can't say that this is 15 root 3 because this 3 and root 3 are being multiplied. They're tied together, so you can't separate them to do this addition. Alright, so we have one piece. We have b. Now let's figure out how to find a. Well, we know that a is just the same as 2 times this short leg. So we found the short leg to be 3 root 3. So we could just take 2 times 3 root 3, and 2 times 3 is 6. So 6 root 3. So then we could say that a is equal to 6 times the square root of 3. So we were able to solve for both a and b. Alright, let's look at one more example. Alright, in this last one we're given a scalene triangle here, or at least it appears to be scalene. And we're given a altitude right here that is the perpendicular from one vertex to one side of the triangle. And then that gives us a couple of angle measures. It tells us that this right here is 45, which means that this down here is 45. And if you didn't remember how to do that, you could just take 180 minus the 90-degree angle here, minus 45, and you would get 45 left over, so this angle is 45 degrees. Alright, so we can do something with these two sides, because if you remember your 45, 45, 90 rules, this isn't going to be great, but if that's a 90-degree angle and this is 45 and this is 45, this is x, this is x, this is x times the square root of 2. And then over here we've got a 60-degree angle given to us, so that means that this one has to be 30 degrees, and so we have a 30, 60, 90 triangle as well. So we have two triangles going on here, and we have to use both rules that we've learned. So the only side that we're given a measurement for is this. So that's the hypotenuse of the 45, 45, 90 triangle. So we need to use that hypotenuse to find one of the legs, and that will actually give us the value for both x and z, because x and z have to be the same measurement. So if 10 is equal to this x times the square root of 2, we can just solve for x to figure out what the side is. So 10 is equal to x times the square root of 2, and then you can just divide by the square root of 2 on both sides. And you'll get that x is equal to, I'm switching these around, but that's okay, 10 over the square root of 2. And so just like we did in the last video, I'm going to rationalize the denominator because we don't want an irrational number down there. So you would get that x is equal to 10 times the square root of 2 all over square root of 2 times square root of 2 is 2. And then simplify. 10 divided by 2 is 5. So you get 5 root 2 for x and z. So I'm going to use a different color and I'm going to write all my answers up here. So we need to find w, we need to find x, we need to find y, and we need to find z. And we just found both x and z as 5 root 2. Okay, so if we know that this side is 5 root 2. Let's go back and review our 30, 60, 90 rules so we can do the other side. Alright, so I'll draw it so that it looks like the triangle that we've got over there. Right, so this side is 60, this side is 30. So we know that when we have a 30, 60, 90, the short side is x, the hypotenuse is 2x, and the long side is x root 3. Well, in this case, we have that x times the square root of 3 is equal to 5 times the square root of 2. So this has the potential to get sort of ugly, but let's give it a try anyway. So x root 3 is equal to 5 root 2, and that's going to help us get what the square root, or what x is. And then once we have x, we can find 2x. So in order to get x by itself, we're going to divide by the square root of 3 again, and then we're going to rationalize the denominator again. So we get 5 root 2 over the square root of 3, And to rationalize the denominator, we'll just multiply by root 3 over root 3, and we will get 5. So your square roots you can multiply when you simplify. So the square root of 2 times the square root of 3 is the square root of 6 over, and the square root of 3 times the square root of 3 is 3. That cannot be simplified any further. So we get that this side right here, which isn't really x, because in our problem it's going to be y, we get that y is equal to 5 root 6 divided by 3. So I'm going to write that in here. 5 root 6 divided by 3. Alright, last one, we need to find w, and we know that w is related to this side, y, because it's 2 times that. So if I just take 2 times my whole quantity, 5 root 6 over 3, this is like 2 over 1 times this, and when you multiply fractions, you multiply the numerators together, multiply the denominators together. So you're going to get 10 root 6 over 3 as your w. 10 root 6 over 3. Alright, so the two problems that we did are probably a little bit more complicated than some that you will encounter, so hopefully it's been a really good practice.